learning objective for this video is to analyze the velocity of an object relative to its time. Now to do that, we're going to be looking at a velocity time graph. Now, once again, quite obviously, a velocity time graph enables us to determine the velocity of an object at any point in time. So take, for example, at 5 seconds, we can use the graph to determine that it is 1 meter per second north, because as you can see, the axis is velocity north. So if it is positive, it is north. And if I want to determine the velocity at 8 seconds, I would determine that it is negative 1 meter per second, which is 1 meter per second south. Now, any section on this line that has a gradient means that the velocity is changing, or that the object has a changing velocity. Now, we're obviously very well aware that a changing velocity means an acceleration. So you can see on our graph, we've got a lot of acceleration going on. And I hope you can already determine that the acceleration can be deduced from the gradient of this line. So let's do a quick example here. So acceleration from 1 to 2 seconds, gradient is our rise over run, and our rise in this case is velocity, our run is time. Velocity over time, as we already know, is displacement. So the gradient in this case will be 2 over 1 equals 2, and therefore giving us an acceleration of 2 meters per second north. The acceleration from 7 to 9 seconds now is another example. Rise over run, minus 2 over 2 gives us minus 1. So in this case now, our acceleration is negative, and because we've been given a direction, we can say it is 1 meter per second south. Now, quite obviously, once again, the larger the gradient, the larger the acceleration. Now, it is obviously, once again, directional. Now, if you understand that, it should be quite obvious that a flat section of the line indicates the object has a constant velocity, i.e. the velocity is not changing, it's staying the same, constant rate. So it has zero acceleration. If that flat section happens to be on the axis, on the zero axis, it indicates that the object has stopped moving because it has no velocity, so it must be in the same spot. I think we should probably, at this point now, just take a quick break.
There I am, Guy here, with a few words on how to catch a lady on the rebound. Oh, that's how you do. Oh, what is this? Ladies love music. Here we go. Are you ready for this? It's Hammer and Guy, your favorite MC. Now watch old Guy break it down. Can't touch this, can't touch this, can't touch this.
That was normal. So a positive slope indicates acceleration in one direction, and a negative slope indicates acceleration in the other direction. So you can see here, positive being north and negative being south. Now, a negative velocity means the object has changed direction. So if it's below that axis, it's changed direction, and it only changes that direction once it gets to past the 0 point. And this is confusing because this wasn't the case when we looked at displacement time graphs, where the direction changed when it reached a peak. In this case, it changes direction when it gets to 0 and goes beyond it. So this motion in the teal is in the north direction, the red is in the south direction. And in fact, anything above the x-axis, or the 0 point on the x-axis, is going in the north direction. Anything below that is headed in the south direction. It's not south of the origin or north of the origin, it's just the direction that the velocity is moving. Now, the best part about a velocity time graph is that it can tell us the displacement that the object has moved. So the way we do that is by looking at the area under the line. So we all know our area is, well, of a rectangle, for instance, is length times width. And in this case, we're looking at the time times the velocity. And we all know that time times velocity, or velocity times time, equals displacement. So if I want to find the displacement from 3 to 5 seconds, for instance, I'm looking at this little rectangle here. So the length times the width is 2 times 1, so it's therefore 2 meters north. And it's north. I know it's north because it is a positive value. So if I wanted to now find the total displacement, and this is going to be really annoying because I've made a very annoying velocity time graph with a lot of different changes in acceleration. So I need to look at all of the area under the graph, and that is below and above the 0 point. So what I like to do is I like to work in triangles and rectangles because they're nice and simple. You can use other shapes, trapezoid, rhombus, whatever you want, but I like to keep it simple, and for me, I know I'm less likely to make a mistake. Now you can see there's a lot, and so it made it a little bit annoying, but all those equations aren't very hard to work out. I end up with an area of 4. Because it's positive, I know that the final displacement is 4 meters north. Hope you haven't had too much trouble following what I've been saying with these velocity time graphs. I think once you apply this knowledge to a couple of quiz questions, you might get the hang of it. If you have any questions, do ask your teachers.
We've had reports that one of our prisoners is missing, but don't worry, Guy is on orange alert and nothing will get by me, Guy.
Hey, baby doll.
Guy likes.